name is Dalit.
And my name's Caitlin. We're here from the Clark Fork Watershed Education Program, otherwise known as CFWEP.
We are on the banks of the Clark Fork River, and we'll be talking about a watershed health measurement today called conductivity. Conductivity basically tells us how well river water carries or conducts an electrical current. Watch out, Caitlin!
So Dalit, what makes water conductive?
Ions makes water conductive. Ions are just charged particles. The more ions in the water, the more conductive it is. If you recall our pH video,
Oh yeah, I do.
there we talked about just hydrogen ions impacting the pH. The more hydrogen ions, the lower the pH. Here, we're not just talking about one ions, we're talking about the total dissolved ions in the water. The more dissolved ions in the water, the more conductive our river would be.
Mountains are eroded by wind and water over millions of years, being broken down into smaller and smaller pieces. From boulders to pebbles, then sand and silt, then clay, and then to even smaller particles that, when dissolved in water, become ions. Some rocks and minerals may dissolve quickly, like halite, or as we know it, table salt. But some will take thousands of years, such as a pebble of granite. Pretty cool, right? This means that every river and stream has a conductivity range primarily impacted by the geology of its watershed.
Typical freshwater conductivity should be between 150 and 500 microsiemens per centimeter. The ions that make that conductivity are ions that actually are necessary for healthy aquatic life, such as calcium, sodium, chloride, and even copper. So, Caitlin, what else can affect our conductivity?
Great question, Dalit. Well, for starters, humans. We have a big impact on conductivity in our watershed. Specifically here in the Clark Fork watershed, it has been heavily impacted by historical mining. Whew, it's getting hot out here. I think I have to take off this hat, Dalit.
Yeah, you're right, it is hot.
All right, so to bring it back, another huge impact that humans can have on the conductivity of our rivers and streams is a typical practice that we all do, and that's de-icing with salts our roads and our sidewalks in the wintertime. As that salt melts the snow and ice on our sidewalk, that snow and ice and water with the salts ends up in our rivers and streams, therefore increasing the conductivity. These particles are so small that you can't even see them with the naked eye.
Which means that it's actually not affecting the clarity of the water. The water is still clear, but it might chemically not be as clean as it is originally or naturally, right?
Exactly. And that's why it's so important to monitor and collect water quality data.
Let's go to the lab and learn how to collect conductivity data and see how the ions affect our data.
That sounds awesome. Let's do it.
Let's go.
Oh my God.
Okay, we made it back from the field.
Oh, phew.
Back to the University of Montana, where we'll be looking at conductivity of different solutions that are clear. They're see-through. You can't see anything in them, but chemically they're very different. So the first couple solutions we're going to look at is distilled water, which is basically purified water, no ions in it, no minerals. And then tap water that does have some minerals, some that we need for sustaining life. Sodium, chloride, calcium, and even copper. So here's a lab quest and a conductivity probe attached to it. And so we'll test the DI water to see what the conductivity is. 1.9 microsiemen per centimeter is the DI water, very low conductivity. So now let's measure the conductivity of tap water. If you guys recall, we do have some ions in there because we have some dissolved minerals. we have 385 microsiemens per centimeter, so higher than the distilled water.
We're going to also be taking a look at a third clear solution with table salt in it. Here is a jar of table salt, and it's also known as sodium chloride. When table salt dissolves in water, it turns into its two separate ions, a single sodium, or a positive ion, and a single chloride, a negative ion.
So Caitlin, what do you think is going to happen to conductivity when we add salt to tap water?
That's a great question, Delete. I think, given everything that we've learned, there's going to be more ions in the solution, so I think conductivity is going to go up. We're actually going to see if I'm right and see if table salt actually does increase conductivity when we put it into tap water. I'm going to measure the tap water right now, and it's at a low conductivity like we saw before, around 320 right now. Delete, can you lend a hand and pour the salt for me?
Sure.
All right. Delete's gonna pour some table salt right in here, and we're gonna, wow, right away you guys, the conductivity shot up to about 3,000, 4,000, wow, 8,000. Oh my gosh, we are getting a reading of 12,914 microsiemens per centimeter right now, you guys. That's a really high conductivity. I was right.
Hey Caitlin, so you were totally right.
Yes.
The more salt we add in the water, the higher the conductivity is.
Mm-hmm.
So we just added a little bit of salt into tap water. Ocean water is also salty.
Mm-hmm.
I wonder what the conductivity of the Pacific Ocean is.
Well, I'm so glad you asked that, Delete, because I looked it up, and it's 50,000 microsiemens per centimeter. Isn't that crazy?
Wow, that is so high. That's crazy. Should we go and measure the conductivity of the Clark Fork water?
Yes, but we have to run there again. Okay.
Let's do it, girl.
Let's go.
Okay.
So let's go ahead and measure the conductivity of our river to see if we are within that range of healthy aquatic life.
And if you guys can remember, our freshwater streams and rivers should be within 150 to 500 microsiemens per centimeter.
Let's do it. 288 microsiemens per centimeter, right in the middle of that healthy range. That's great.
That looks cold.
Of course.
Thank you so much for watching this video about conductivity. We hope you enjoyed it.